Right, yeah, so I'm going to talk about Puppet as a legacy system. Basically, I'm going to take Puppet as a good example of something that we adopted relatively early on, quite a while ago, and explore some of the interesting situations we got into with leaving it the way it was for quite a while. I'm probably going to provide a fair amount of background into our current migration. So let's just get started with a bit of background. So I work in IT services at the University of York. That's basically the university's central IT function, and we use Puppet to manage most of our Linux infrastructure. All of our Linux infrastructure. I don't think there's any Linux left that we don't have Puppetized. It started in 2008, roughly, a bit before that possibly. That's as far as our SVN history goes back. So that was before I joined. I've been at the university since summer 2012, so not very long in the grand scheme of things. We are currently working on an upgrade to Puppet 3, and in doing that, what we're doing is we're actually replacing the infrastructure rather than just trying to upgrade the stuff we had already, and I'll get to the reasons behind that. So just to look at how our core repository is developed, the blue blocks shows the number of commits in a given year. And then the lines show the number of node blocks we've got, the number of modules, and then the green one at the bottom is the number of external modules we're using, for example, off Puppet Forge. And what I thought was quite striking was the rate of commits increases with the number of modules, which basically means we're spending more and more effort on maintaining our code rather than adding to it. So, I mean, we have 130 modules, in excess of 130 in-house modules. That's a lot to maintain, because I mean, you know, our main job isn't managing Puppet. Our main job is running services. So we develop services, we upgrade services. That means that we need to, you know, write new modules and maintain old modules. Alongside that, the Puppet tooling and the language is evolving. So we need to deal with things like style changes and where certain things become deprecated and we really shouldn't have been doing them in the first place. And with that many modules, you've got a lot of scope for knock-on effects. So you change something fairly minor in one place and then you find that it breaks something somewhere else because you've got a resource with the same name or something like that. Or you end up with a dependency loop that you couldn't have possibly seen. And with that number of modules also, you get these confusing code paths. So you will occasionally go to a server and you'll build it and why does this have central authentication on it? Where did that come into the mix? You know, and you trace it down about 8 levels deep somewhere. It's been pulled in by something because that module decided that it wants it as a dependency. But it's not always obvious why. The other thing you get into, which I think was mentioned in a talk this morning, was you can have namespacing problems because of the way the Puppet namespace works. If you have a lot of modules in it, you have a lot more potential for getting clashes there. Either just between the modules that you've got in there, or when you want to import new modules off Puppet Forge, you've obviously got a lot higher scope to have collisions between the names of resources and things. So Puppet's improved a lot since 2008. We've got things like exported resources and we've got better integration with Hire in Puppet 3. So basically that makes it easier to pull in more subjective data about nodes from a source that's not the same as your Puppet code. Environments provide a lovely way of isolating your dev and test environments, for example. Puppet Forge is a good way of getting code that other people have written or that you want to share with other people and keeping pace with that. And then Puppet File is a way of automating getting those modules from Puppet Forge. And the thing with those was, with our old infrastructure, a lot of those were going to be difficult to do, just because of the way it was put together. So we felt it was quite out of reach with our existing infrastructure. With changing Puppet versions, Puppet 3 really is nicer than Puppet 2.7. And there was a lot of stuff that was deprecated in 2.7 that had hung around from the very early code bases. And finally got rid of stuff like dynamic scoping, which made it almost impossible to tell where values were going to come from and was very commonly used in early Puppet code. So the opportunity to actually get rid of that and make sure that our code was free of it, it was quite handy. The other thing is with those improvements you get changes in style. So if you look at an example of a good Puppet module from 5 years ago, it probably doesn't look a lot like a good Puppet module from the current day. And that's because things like the structure changes, people learn how to use the language, the capabilities of the language make more options available. But we still have a lot of legacy code that was developed early on and which we've really not taken the time to rewrite because there's a lot of effort to, when you've got 130 modules, rewriting them all is a pretty mammoth task. So the situation at the beginning of this upgrade process really was that we had this massive SVN repository with a bunch of Forge modules manually imported in it. And like I say, you're going to have problems when you've got to that size of repository. Really, we should have maybe acted a bit earlier. In terms of the infrastructure, we had a live Puppet Master, which is Nginx and Mongrel, which I think is now basically thin. We had a backup Puppet Master, which was apparently the same as the live one, but we had no guarantees of that. We don't know whether we'd maintain them the same. And then we had a development Puppet Master, which was running lots of separate Puppet Master instances to provide, to essentially serve up all the different SVN branches we had. And then we had a server to do the Puppet CA and host the SVN repository. And like I said, all of those servers were basically manually configured, so we had no way to sort of recreate them easily. So we hopefully have learned the lessons from that. We had a previous upgrade a couple of years back to level all our systems at Puppet 2.7. We got there quite well. I think there were a couple of Solaris boxes that ended up running Puppet 0.24 for a while, but we've got them sorted now. But the main thing was we got the Puppet Masters upgraded and got all the deprecation warnings that come along with 2.7. And that gave us a good opportunity to sort of weed all the bad code out, all the stuff that was using things it shouldn't do, before we had to touch 3. At the time, we were hoping to start using Hiera to store some of the data, like things like database passwords and SSL keys, things like that. Not good to really keep them in your Puppet infrastructure, inside your main repository. But in the end, that dragged on so much that we decided we might as well wait for Puppet 3 and get the nice Hiera integration that came with that, because Puppet 3 integrates much better with Hiera than 2.7. You don't have to do as much manual work or boilerplate to get the same effect. So really, eventually it came down to, right, we really need to do this. And there are 3 main reasons that. The first one is that support for 2.7 was gradually dying out. Apart from sort of rumours of it was becoming end of life and wasn't going to be supported, I don't know if that's actually true or not. There are a lot of Forge modules now that use Puppet language that really need it to be running at least Puppet 3 on the servers. And we don't like having to rely on backport fixes. It can be, sometimes it can be a long wait, sometimes patches don't ever get backported. It's better to just go with the flow, run the newer versions, and get the benefits of that. The second thing was that we started installing Ubuntu 14.04. And when we did that, we realized that, okay, this is shipping with Puppet 3. We really don't want to downgrade packaging on new OS. That seems like the wrong thing to do. And we didn't like all the badgering in the syslogs that we're running a 3.4 agent against a 2.7 master and you're not supposed to do that. It fills up syslog and it tells you you're doing it wrong. And like I said, the better feature in Puppet 3 in general, especially things like Hiera integration, were a real thing. Look, let's just do this. Let's choose to upgrade. So the upgrade path, the usual thing, please don't break anything. Yeah, great, new Puppet, don't break my servers. And we've got a massive diversity of systems. That's why we've got 130 modules. We have a massive array of different systems that perform different functions relating to the university. And we have a lot of different groups of users, between staff and students and researchers. And also, those systems tend to have particular critical periods. If you take down student information systems during the A-level results period, people tend to get quite irritable. That's sort of career-defining stuff. And 130 modules, that's a big number, and with that amount of code, it's very easy to miss something, whether that's because you're manually scanning the code trying to find instances where you're using a particular style, or because you're doing regex replaces on things and you've not got it quite right. There's a lot of scope there to get things wrong. So essentially we said, right, we're not going to just upgrade the current Puppet Masters to 3 and do it that way. Why don't we build something new that works, migrate all the clients across to it, and then get rid of the old stuff later. Like I said, we were running Nginx and Mongrel for our Puppet Masters. I don't know whether, I assume that may have been the best thing to run at the time, but these days a lot of people run Apache and Passenger for the Puppet Masters. And really, we came down to the decision that if you choose a configuration for something that's fairly typical that a lot of other people are using, it makes it a lot easier to get support. Whether that be because you directly ask questions and you say, yeah, I've got this set up, or whether it's because you find something that doesn't seem quite right, and you go into Google and you search for the error message you're getting or whatever. If your infrastructure is similar to other people's, it's a lot easier to relate the bugs you think you're seeing to other bug reports. If you're running a really esoteric system that's based on things that people really aren't using, you're going to find it a lot more difficult to support yourself. The other thing was that with Apache and Passenger, there are packages available for Ubuntu that will install that stack for you, and there are Forge modules available that make it really easy to configure that. The other thing we found, a lot of people in the Puppet world, I think everyone in the Puppet world is using Git for managing the repositories and providing external modules. We were using SVN, so we thought, well, everyone else is doing this. Why don't we do whatever, again, let's do what everyone else is doing. Maybe we'll get some automation benefits. And we also found a lot of people using dynamic environments. Just quick show of hands, how many people here are familiar with Puppet and environments? Yeah, a good number. So we'd previously used, as part of our Linux desktop project, we'd used environments, which was the old static environments where you essentially said, this is the name of the environment, this is the directory the configuration's checked out under. When we discovered dynamic environments, like, oh, this looks good, because essentially you can say, whatever branches you have in your repository, let's have environments that are named after them. So it makes it very easy to bring up a branch for testing or developing something and run your dev nodes against that. And you don't have to do any manual labor to get those environments running on your master. One thing we didn't spot immediately was the limitations of environments page that Puppet advertises. We found that later, and I'll come back to that. The other thing which we found that was really good tooling around R10K to get the contents of your repository checked out efficiently into your Puppet master. So, like I said, new infrastructure design, we try to be typical. We made sure we can get the features we want, so we make sure we don't lock ourselves out of anything by virtue of whichever way we set things up. And we learned that building the Puppet masters manually is not a great thing to do because you lose that ability to track what changes you've made, and it's generally slower to develop them. So we decided to do a Puppet build Puppet master, which obviously is a bit of a chicken and egg problem. You need something to start with. Puppet apply is quite helpful here. So essentially what we started out with on these was we built them semi-manually. We installed the packages and we set up a Git repository. And we essentially did a cycle of install Puppet and then run Puppet apply to bring up the rest of the system. And then essentially, it's not changed, has it? We iterated on that. So once we had a single Puppet master, we developed it until it was basically working. Brought up a test master based on that so that we could start running some servers against the other one. And then we eventually rebuild that infrastructure completely so we no longer have the original manually built master. So yeah, it's essentially what I was getting around to here. I'm not going to dwell on it too much. Is essentially we've replaced the first manually created master with another one, and we're confident that as long as we have one Puppet master, it's easy to rebuild the others, whether it be off the test or off the live ones. And once we had those set up, we just set up the Git and the Git branches so that we can work on the test master and iterate really quickly, and then merge the changes onto the live masters once we're sure that that's what we want to do. And that's really how we're sort of hoping to go forward with Puppet in general, is working on a staging system or working on dev branches if it's more in-depth work. And then you can do that, whether you're in a critical period for a system or not, because you're not working on the live system, you're working on a test version, and it should be isolated. The other nice thing, especially with the test Puppet master, is because it's no longer building off itself, if you break it, it's not a problem because it's still got something to refer to. In those very early days of having the one Puppet master building off itself, you can get into the situation where you've basically unconfigured the Puppet master and it can no longer build off anything, at which point you have to bootstrap it again. Really nice thing with the Git branching is that if you've got change management processes, it's very easy. If you've got a staging server that replicates your live servers, you can very easily test what your branch is going to do and use that as a basis for your change management process to say, yeah, we've tested this, we have a replica, we can guarantee this is how it's going to run. So yeah, our old systems, you basically ran a script if you want to create an SVN branch, and then you ran another script to bring it to a master, and it took quite a while. SVN branching is essentially a full file tree copy, which is quite slow, especially when you've got that many modules. Whereas Git branching is basically instantaneous. So we have this new situation where we have no excuse to develop in production, but we still have the power to allow our admins to tweak where it's necessary. So if there's just data changes or things like that, minor tweaks, if there's an emergency, they can do that. The other thing we want to get with dynamic environments that we saw as a real benefit, we have external departments and external groups of people within the university who want to manage their systems, and we want to encourage them to do that in a modern way and use configuration management. So with dynamic environments, with the tooling available, we can just give them a repository and they get exactly the same benefits as we do off the same infrastructure. How many of you have heard of R10K? Yeah. Are you all using it or just heard of it? No. Yeah. Okay. So I mean, for those of you who haven't heard of it, it's basically a wrapper around Git that does, it's very biased towards Puppet, and it does quite good caching, so it will do things like making sure it has one copy of the remote repository, and then instead of ending up with n copies of the same data, you end up with one copy of the data and then hard links for the environments. So you don't end up with this massive bloat every time you branch, you double the size of the stuff on your Puppet master. It's much, much lighter than that. And because of that, it also makes it a lot quicker to check out things. So it'll also do you creating your environments based on your Git branches, and then purge them when you remove those branches. And one of the nice things about it is you can prefix your repositories, and this comes back to delegating to other departments. Essentially what we've set up is each repository has its own prefix. So for example, our repository is prefixed with ITS. And that means that all of our branches are basically named after repository name underscore branch name. And it's really easy to figure out what belongs to which repository and which branch is it. So when we add other departments, all we do is we give them a different prefix. And it means that they can have branches that are called names that are similar to ours. So for example, production. But because of the prefixing, there's no sort of way that you can get a name clash. R10K supports Puppet file. How many people are aware of Puppet file or what it does? No, yeah, a few of you. So essentially, if you want to use a Forge module or an external module off GitHub, Puppet file lets you just declare that once in your repository instead of actually importing all the data, and instead of using any tooling to go and do that by command line. Essentially, you check Puppet file in your repository and R10K can pick it up and say, oh right, you want version 3 of the standard library? Sure, I'll check that out. It makes it really easy and very obvious in your diffs when you've changed the module version, because it's just one line in that file. It's no longer remove all these files, add all these files. So it's quite efficient. A thing we found quite early on actually was it started getting slow. And it was only when I looked into exactly how it works that I found out what happened. So, like I say, we have all these separate repositories for departments to start using. And that gives us the nice isolation on the Puppet Master. But each time you run R10K, it wants to purge any directories that don't exist anymore. So it needs to know which branches exist on every repository. And what that actually means is that every time it runs, it has to go and fetch every repository to see what branches are there. And basically, because R10K, it's essentially just a Ruby gem at the end of the day, we started using it in a library and we just bolted some logic on the front because we don't really care if there's, if there's an environment that was created and it doesn't get destroyed for a day. That doesn't matter to us. What matters is that eventually it goes into the right state and we get the things we want very quickly. We don't want to be waiting several minutes every time we commit just because it's gone to fetch all these repositories. So from our Git system, we can tell which repository was pushed to and then look at the R10K config to turn that into a name that R10K recognizes by its tag. And then we can just say, well, go and update that environment. And don't do a purge because I know that if I ask you to do a purge, you'll go and fetch all the others. And the other thing is we can hook that in to say, is there a Puppet file? Yes, no, deploy it, don't do anything. And then essentially because this is a cache tight operation, we've got a nightly run that just does a full update and purge, basically using R10K's regular routines. So we get the benefits of having the quite snappy behavior when we push something. But we can guarantee that even if our logic isn't quite right, things will end up right overnight. Now, I said earlier about the drawbacks of environments. How many of you are using Puppet environments? How many of you have read that web page about the limitations of environments? Okay, that's the situation we ended up in. So we thought dynamic environments, great thing there, nice and snappy, handy for the devs. Wait, what do you mean? So you're saying these aren't actually isolated? And this is not something that is really the fault of Puppet Labs or the developers. We didn't have to worry because at the time we didn't have anyone else using it. So we knew that if something did break, it would be our own fault. And because we weren't using, I think we were using 2 of the repositories at that time, and they fortunately didn't clash. The issue comes from the way that native Ruby plugins work. Because the Puppet Masters work as a process, once they've included, for example, if a module depends on a Ruby gem, once it's imported that once, it's not going to be touched again. Or if it is touched again because something doesn't know about it, what you will get is a possibly mangled mess of 2 modules, not one or the other necessarily. And essentially, you can't fix that within Puppet because it runs as native Ruby. Once the Puppet Master process is started, its global namespace can start being polluted. So essentially, what we ended up doing in the end was we stuck a workaround at the web server level. And basically, we tell Passenger that for each environment, based on the URL coming in, assign it to a different process group. So we can guarantee that if there's something for ITS production, it's not running in the same process group as the ITS dev stuff. So if we upgrade a module, we can have true isolation between one and the other. The only bits that aren't isolated are the things relating to exported resources and PuppetDB. And how that behaves is in fact a bit interesting, because if you're using exported resources to set up testing, for example from Nagios, you don't necessarily want to isolate those environments. You may want Nagios to pick up all your tests from everything. So there's a bit of a question there as to what is the behavior and what's the desired behavior. But in terms of the working around native plugin name clashes, we believe we've worked around that successfully. We saw a couple of other bugs that were related to that, to do with the master not picking up certain native resource types. That's fixed. There's a fix for that. I don't think it's fixed on 3.7 yet. In terms of the actual migration work, we have over 350 Linux hosts to migrate from 2.7, and that was a mix of Red Hat, CentOS, Oracle Linux and Ubuntu. Obviously we didn't want to do that manually, so we actually ended up using a shell script. This wasn't your standard shell script of just do that, do that, do that. There was a fair amount of testing of, did this work? Ask for confirmation, things like that. And it was really because we couldn't have Puppet upgrading itself. We didn't feel that it had the capability to do that in a safe manner. So we essentially wrote a script that will uninstall Puppet, install the new version with a new config, and then let you do a no-op run to make sure it's all okay. And that also handled switching from the old infrastructure to the new infrastructure. We ended up recycling that eventually to produce what we use post-installation. So we actually build Linux boxes using the operating system installers on VMs. And then we use a script that's derived from our conversion script to actually bring up Puppet as the current version that Puppet Labs ship. We basically started out doing the test upgrades to make sure the script worked okay on our test and dev boxes. If they went down, it wasn't such a huge issue, but at least we hadn't lost any live infrastructure. And basically we iterated that script until we'd got something that worked and we were confident with it. This is a happy graph. This is in fact of last week. It's got even happier since then. This is the space of around a month. The big bands at the top at this end are Puppet 3.7. So our rollout went quite smoothly once it got going. You know, the big rush about here, and then some things had to wait. We had some interesting situations. We had a situation, the Linux desktop stuff is still running Puppet 2.7. And because it's a Puppet master that's configured by Puppet, and the way the dependencies in the packages works, you can't have Puppet 3 agent and Puppet 2.7 master running side by side if they're the package installed versions. So we had to figure out what to do in the meantime. So that's still actually running 2.7. We still have some other stuff to do, like we still actually have to do the repository migration. At the moment we're using this horrible bridge using git svn to check our svn repository out as a git repository and then pull that. And we really need to clean up our existing code base. Because like I say, we have a lot of legacy code that's using a really bad style. So what we're going to do there is we're going to migrate to a new repository and migrate the code as we need it. And then we can migrate the systems across to a different environment as we do that. And hopefully eventually the old code can just die. And again, like the actual infrastructure migration, that gives us the chance to develop new, better code without breaking a lot of systems that are using it. We still have to implement Hira. We're very confident that we're not going to let this one drag on like it did with the last upgrade. But we're still trying to sort out the fine details of how we implement it, whether we have a Hira with the Puppet repository or whether we have some system where there's maybe one that's shared between all the dev instances. That detail we've still to figure out. There seem to be a lot of differing opinions on the internet. The other thing, that this is primarily me I think, is teaching other departments how to go about writing Puppet. And that's challenging when you sort of trying to figure it out yourself. And you know, also there's a fair amount of people within our department who probably want to also learn what's the best practice at the moment. And then we get rid of the old stuff. That'd be lovely. So just to sort of relate this back to the brief. I want to start with the downside of early adoption because I think it would be nice to just address those first. We ended up with loads of old bad legacy code. You know, when you're working with a tool that's not particularly mature when you start, you're probably going to find that a lot of the styles change. Because we've been using it so long without upgrading to more mature versions, we have a lot more systems running that are running against the old bad code, and that we have to worry about when it comes to migration. And as I sort of addressed at the beginning, we came very close to sort of getting to the limits of that single repository with having 130 modules. We're getting to the point where we want to use more Forge modules, but we can't because the names are the same as some of our internal ones, and we're still using them. When you've got something that's very bespoke, that's built before a lot of people have adopted and decided what the best way to go about things are, it can be very difficult to integrate newer features, which is one of the reasons that we did replace the infrastructure rather than trying to upgrade. I wasn't there when it was first used, but I assume there was a lot less documentation at the outset of using this. Certainly now there's a massive community around Puppet. You end up with ingrained tooling if you adopt things early. In this case, we're using SVN, and there's a lot of automation built around that, primarily with scripts, and we just need to get rid of that, and figure out how to move people onto Git quickly, but in a controlled fashion. As I mentioned before, we had a manually configured Puppet master. I feel that's horribly, horribly hypocritical. But obviously I understand why it was done. When you're starting up there, you probably don't want to have Puppet managing Puppet master when you've not used it before. It sounds like headache. And if you adopted something very early, you can end up with a lot of old stuff to get rid of, partly because of the legacy code, partly just because of the way things evolve. But I'd like to move on to the sort of brighter side of things. Through this, we've gained a lot of experience working with Puppet. We've seen it grow. We've seen things that sort of, you shouldn't have done it like that, and the styles change. And because you've had that experience, you have a much better grounding of why we do things in certain ways and why we don't do things in other ways. And you can learn to look at your own code and go, yeah, that's not so great. We shouldn't have done it like that. With a bit more sort of depth of time there, it's a lot easier to see the things that are really annoying. Things like waiting for syntax checking on check-in. Our syntax checking takes about a good minute if you check in a small change, and much longer if you check in a large change. We know that that's annoying, and we know we don't actually get much protection from that syntax checking. But also things like branch creation. At the beginning, maybe the branch creation wasn't seen as a massive benefit. These days, probably a lot more so. A lot of people are using dynamic environments to isolate their test instances. And we see now that, yeah, it's very convenient if you can just spin up a new environment. That's a great thing to be able to do. You get a lot of depth of knowledge into how your infrastructure actually works. If you adopt it from the beginning, you can see as it's changing, each time something breaks, you can say, well, why is that broken? What have they changed in this release that's made that stop working? And you can sometimes get a much better appreciation of why some decisions have been made the way they have. Above a lot of things, we adopted early, and so we've had the benefit of having a configuration management tool for the past 7 years. That's a long time. Whereas if we adopted later, we wouldn't have had so much benefit from that. Maybe we would have had a slightly different experience from using a slightly more mature tool. But we got in there early, and we built up experience while when we could. And like I said, it's sort of similar to understanding automation. It's understanding the benefits of when it can be useful to have development environments and test environments. When you're working in a small production repository, it's maybe not as obvious because you can tell where your changes are going to impact stuff, and it's only when you make logic errors that you realize that, yeah, we should have had a test environment. But when you've got a massive repository and you're talking about renaming your internal modules so you can bring in Forge modules, you can get a better understanding of, yeah, that's the sort of thing where a test environment is really killer. So just to bring a bit of a summary, yeah, our infrastructure crept up on us, the size of our repository just got unwieldy. If you can identify when your infrastructure's looking a bit difficult, then replace it as soon as you can. Like I say, identifying that is probably one of the hardest things. In hindsight, it's a wonderful thing. We could have said, yeah, when we had 100 modules, it was too many. But at the time, we weren't experiencing the issues. So sometimes you need to take a bit of a step back and saying, well, hang on, how could this break? And that's a hard thing to do sometimes. And the other thing is, put effort into getting a shiny system that does what you want. This is where we dropped Hira from our last upgrade because we knew that it was better integrated with a new version. So why would we expend loads of effort there when we could have started a new upgrade and get those features basically for free? Development on a non-live system. Now, this might seem obvious to a lot of people, but when you're used to working on essentially your production repository, you feel, well, yeah, I know what this is going to do. This is a minor change, that's great. But there's always that little doubt in your mind. When you're actually working on non-live system, it's brilliant because well, if it breaks, who cares? It's not affecting anyone else. It's not stopping anyone else doing the work. From doing the Puppet Master stuff with Puppet, I learned very quickly that, well, yeah, this is great. As soon as people start to use our live Puppet Masters, I had to think a lot more carefully before I released changes on them. And it was only when I realised that I got a really good handle on how handy it was to have that test master there that I could just say, well, okay, we need to fix this problem. Oh, that's broken it. What happened there? If had that been on the new live Puppet Masters, yeah, it would have dropped some dev servers in it, but the point was that could have been an inconvenience to someone else and blocked someone else's work, so you don't want to go there. And really, finally, early adoption is a balancing act because you're going to probably need to change some of the stuff you implement initially. As we have, basically doing it over is, maybe a harsh way to learn that, but being aware that if you adopt a tool early, you're probably going to need to change things as that tool gains maturity. Being aware of that is a very useful thing. But also you can gain a lot of knowledge from working on stuff from the start. As we've had a lot of experience with Puppet and we've seen a lot of different ways of not to do things. And that really brings it home when you see why are modules structured the way they are. Why do people run spec tests against these? But along with that, and along with being prepared to make changes to your infrastructure, if you're working with something that's a very immature tool, when you start, you need to be prepared to pay in effort or in costs later on, just because of the amount of stuff that can change. So that's about where I want to leave it with the presentation. I'm open to questions, or if you want to discuss anything, that'd be great.
At the point where you provision your new Puppet 3 Puppet Masters, am I correct in saying you just ported all of your 130 modules?
That was done slightly afterwards. Initially, we actually ran the master up just with its own Git repository that provided its own configuration. We worried about joining on the 130 modules later, but we basically said, well, we know we're going to want to divide up into our environments, and it seems sensible that the master should be isolated from the rest of our hosts, just from a point of view of, if you break them, you've broken everything potentially. So initially we did run it with just its environment, but quite early on when we wanted to start running our regular dev and test hosts against that, we sort of invented this kludge using git svn to check our svn repository out. And again, we're going to have to pay in some effort to actually get that converted.
So why did you not instead take a decision to try and replace as many of those as possible with Forge modules?
It was really a case of time available. Because our main focus was to try and get our infrastructure all up to date. So our agents were running Puppet 3, and we were running the Puppet 3 master, so we could take advantage of the new, the newer syntax where we could, and the newer features. So really, replacing the old code was a secondary thing. That's why we decided to have a new clean slate to start on soon. But really it was a case of we need to get all our stuff upgraded, and we want to do this with ideally as little change as possible. When it came to upgrading a host using that script, essentially what we were doing was saying, right, we've upgraded Puppet, and if we've done it right, there should be no changes. And that's what was our measure of, has this host been installed successfully? Was, has it processed the right Puppet manifests, and have we got something that is in fact producing 0 to very few changes? And I think the only thing we had on most hosts was that the ID tags we were using in SVN became blank because Git doesn't read them. So yeah, that was it. It was really that there wasn't enough time to go about replacing those modules. But we would revisit it once we had the infrastructure to do it more sensibly.
How much code did you have to fix? So, I mean, with those, amongst those 130 modules, there must have been some arcane ones that were using syntax that wasn't supported.
There was a bit. I mean, this goes back to the last upgrade to Puppet 2.7. When we did that, we actually looked at all the deprecation warnings we got out on the master, and we used them to really fix up things where we had things like dynamic scoping. So basically, that really did give us a solid ground for saying we're very confident. There were still a few things that did change. I think in the host site upgrade, I only had to make one code change, but I think earlier on, there were certain things we had to work around, like the fact that import in our legacy repository, our site PP just says import everything under our nodes directory. Now under Puppet 3, the default for your site manifest is in fact the entire contents of the manifests directory. So we had these strange warnings about circular dependencies because essentially it was, well, you've already included this path, but it wasn't from the import. So we had to fix things like that, and actually we had to work around that because we still wanted to maintain compatibility with our old masters until we had everything off them.
We have 35,000 lines of just .pp Puppet code in that repo, so not including, .xml, so templates or anything else, just pure Puppet code. So it's quite a big pile of code. It's another reason for not wanting to change too much at once.
Yeah, sure.
It does help that we've sort of, for a couple of years now, we've been aware of the things that we shouldn't be doing anymore. So a lot of our newer code has already been written in a manner that will work on Puppet 3, and there will have been ongoing maintenance where people have spotted things and thought, well, that doesn't look right, we need to do that better. So there will have been a gradual phase out, probably quite invisible to most people.
I was wondering how you are triggering the RTK events. Is this part of the custom to the script around that?
What we do is essentially on check-in, on push, our Git server SSHs into the primary Puppet master and runs R10K via this Ruby script.
So just like commit hook.
Sorry.
So just like commit hook.
Yeah, it basically is a commit hook. The only additional place it will trigger is we have a code path in so that if we have modules that are in separate repositories, we can make it deploy them if it can. So we can track things like branches, whereas otherwise you'd need an extra commit to the core repository to update it. But yeah, it's just really done on commit hook.
You mentioned your stuff is in Git. Is that publicly available so other institutions can sort of see how you did it?
Do you mean the Puppet Master stuff?
I mean like all your modules and stuff. So you've done all this as well as the migration. Other universities might want to be able to sort of look at it and go, oh right, we could do that, and we've already got something to work with, if you like.
In terms of the Puppet Master stuff, we probably could look at sharing it. We don't at the moment, just because it's on an internal server, and that's what we're using to hook into. For the Puppet Master stuff, we probably could look at sharing it because I think it would be very useful for other institutions. For our actual core repository, we can't do that at the moment because it's still full of things like database passwords and stuff that all need to be reworked. But yeah, we could probably share some of our stuff. I mean, a lot of it is using stock modules for the Puppet Master setup. We just sort of glue it together in the way we want.
Yeah, quite often the glue is the bit that's missing from...
How you set your system.
And it's also an example if like, say I wanted to push it at Manchester, being able to say, hey, York have already done it. There's the proof, if you like.
Yeah.
It's kind of a good case rather than just, somebody at a conference said it was a great idea, so we should do it.
Yeah.
Even though we can't make it public, if you want to come across for a day and we'll talk you through everything, show you some code, that'd be fine.
Have you looked at the stuff that's coming in Puppet 4? And if you have, has it kind of changed your process?
Puppet 4, we've not done an awful lot of looking into it. We have had our first sort of request of why does this not work, and the answer was because we're not running Puppet 4. It's basically it's sort of quite high up on my to-do list is to look at Puppet 4 because really we designed the infrastructure to be as modern as possible so that when it comes to Puppet 4, we'll have a much easier upgrade than we did from Puppet 2.7. But yeah, I need to look at the feature set really to see what's changing. I am aware of things like Puppet Masters being replaced with Puppet Server, but that doesn't really bother me much because I don't really care how Puppet Master itself works or whatever fulfills that function. What I care about is will our dynamic branches work and things like that.
And what was interesting / worrying from my perspective about where they're moving to is that they're now going to package Puppet and Impetus, so have its own version of Ruby, its own version of OpenSSL, all a great big binary package that installs on the right /ops Puppet license.
I can see why that would worry people. Yeah, that does sound a little worrying, but yeah, it'd be interesting to see how it works and why they've made those decisions. Any more?
Just quickly, I wasn't entirely clear from your talk about environments. Are you testing are you deving and testing your Puppet code on your production Puppet master with environments, or are you testing on a test Puppet master?
In terms of this becomes confusing. In terms of the actual environments that set up the Puppet masters, we are running the live checked out repositories. We're serving those from both the test master and the live master. But in terms of what is configuring those servers, the test one is running out of essentially the master branch, and the production servers is running off a separate branch. So in terms of the actual configuration that's being applied, the test one is getting what's on master, and the production ones are getting what's on the production branch, essentially so that we can... The reason for doing it like that was essentially so that we can test that our live repositories are working correctly on the test master. Because obviously the Puppet master's function is to make sure the catalogs are compiled correctly based on our code. So we need the live code available on the test master, but it runs a different branch, so we can test when we make changes to the Puppet master configuration. We can test that on the test master to make sure that it's serving out what we expect. So, for example, when we patched Puppet against Pup 15.15, which is an environments-related bug, when we did that patch, we obviously had to make sure that that wasn't going to break something on the live masters. So when we changed the configuration to essentially apply that, there were a couple of other things as well. We could take a server that was running on live and just do a single run against test and make sure that no resources changed. And that gave us a good proof that, yeah, it's compiling in the same way. There's no knock-on effects to it.
So you're using the test Puppet master for testing configuration changes to Puppet itself, yes. Right? So if I've got a server where I'm just testing new Puppet code, you would still do that against just an environment on the production environment?
Yeah. So if you were testing, for example, you want to upgrade the standard lib module, you'd just create a Git branch that pointed to a different version of the standard lib module, and then that would be checked out on the live Puppet master. And we're confident in doing that because of the workarounds we applied to the environment limitations. Normally, you would have interesting problems with native resource types clashing. So yeah, be aware of that. If anyone wants details on how we've worked around the environments thing, I'd be happy to give more details. I can make my email address available. It was at the beginning of the presentation. I possibly should have stuck it at the end. Yeah, if anyone wants my email address to ask about that workaround specifically, or you want to ask me any other quick questions that you've not had time to today, please feel free. I'll do my best to answer them as I can.
Is there any other questions? Excellent.